This is review number 1 for Unit 6. This is review 6.10. This is going to be question number 12, 14, and 16. All right, so number 12 here, it says to solve for the constant of integration given the derivatives and the point of the original function. So we have the derivative, we integrate to get back to the original function. All right, so when I do that, I'm going to be solving for my original function here, f of x. You integrate, the integral of secant squared, you're going to have to remember is tangent of x. Remember, trig functions have their own set of rules. You just kind of need to remember those. All right, and then this is going to be plus cosine of x. The integral of negative sine of x is cosine. All right, be careful with your negatives there. All right, and then from here, you're going to have that plus c. So typically, we'd be done at that point. That is our original equation after we have integrated it. But now I want to take the pi over 4 for my x and my 1 for my y, my f of x, and plug them in so I can solve for my constant of integration. So 1 is going to equal to tangent pi over 4 plus cosine of pi over 4 plus c. Technically, you can do that without a calculator. But the easiest thing to do is make sure you're in radians. Type this right on the right side here, tangent pi over 4 plus cosine of pi over 4 in. Subtract it from your 1, and you get negative 0.707 is equal to your c. So here, y is equal to tangent of x plus cosine of x plus, or I'm sorry, minus, since it was a negative, so minus 0.707. Again, you should recognize that 0.707 is root 2 over 2, so an even better answer would be instead of the minus 0.707 would be minus root 2 over 2. Right, but this is acceptable since we were rounding 3 decimal places. All right, so now scrolling down for number 14. So 14 and 16 here, we're going to be using the fundamental theorem of calculus for area to calculate the definite integrals. So these are definite integrals because the bounds are defined. Right, they're defined on the top and the bottom, so the lower bound and the upper bound. So number 14 here, I'm going to integrate my x and my negative sine of x. When I do so, I end up here with 1/2 x squared plus cosine of x. And I'm going to simplify that from the pi over 3, my lower bound, to 5 pi over 3, the upper bound. So again, this is my f of x, a big F as we've been calling it. All right, so now when I do this, I'm going to take my 5 pi over 3 and pi over 3 and plug them in. So this is f of 5 pi over 3 minus f of pi over 3. And then when I simplify that, I'm going to end up with 1.513. Now remember, when you're doing that, easiest way to do this is to plug this into y1, use your calculator, do your bars, y bars, and then solve it using your y1, 5 pi over 3 minus y1 of pi over 3. All right, number 16, same exact type of an idea here. All right, so this time we're going to integrate 3x and x squared plus 2. And the bounds I have are from 0.6 to 1.3. So the first thing I'm going to do is I'm going to find my u. I need a u here because these two are being multiplied. So u is going to be x squared plus 2. Derive that, du is equal to 2x dx. And now I'm going to be able to replace. So I'm actually going to be looking at this in a couple of different ways here. So first, I'm going to rewrite my integral here as 3x and then u to the 1/2, again 3x, the u to the 1/2. And now when I replace this, this is going to be du all over 2x. So notice the purpose didn't write the bounds on there, and I'll talk a little bit about that in another minute. So here, the 3x over 2x, first I'm just going to simplify this. So 3x over 2x is just 3 over 2, u to the 1/2 du. And now I need to integrate this. Add 1 to the u to the 1/2, u to the 3 over 2. Divide, so the 3 over 2 out in front goes away. So I'm really left with u to the 3 over 2 here. Now this is where you have two different options. All right, so what are my bounds going to be? All right, one way to do this is you can take your 0.6 and your 1.3, the original bounds, plug them into the x squared plus 2. So if you take 0.6 and plug it into there, you end up with 2.36. If you take 1.3 and plug it in, you end up with 3.69. And you can integrate from here. So this would be f of, or not integrate, I should say. You can simplify from here. We've already integrated. F of 3.69 minus f of 2.36. All right, and that is the preferred way of doing it because it's using simpler bounds. And as you do these problems, as you get more and more into this, and possibly into college, and you can't use a calculator, this is probably the best method to do it. Your answer here is going to be 3.463. Okay, so what if I wanted to do this a little bit differently? All right, so from here, after you integrate, you're going to end up with u to the 3 over 2. That's still true. All right, well, what if I want to replace my u with my x squared plus 2? That's fine, you can do that. So now this is going to become x squared plus 2 all to the 3 over 2. And the bounds that you're going to use for this are going to be the original. So this is the 0.6 to the 1.3. All right, so these bounds, again, are in terms of x. These bounds over here are in terms of u. That's why we converted it, the original bounds to the u. So now this is going to be f of 1.3 minus the f of 0.6. And when you do that again, you're going to end up with the same answer, 3.463. Either method is acceptable for me.